Hi. Finally, come to our last part of techniques, integration techniques. Part B, definite integrals. In definite integration, the constant c of integration is ignored. Okay, so we don't need to write c anymore. We use the fundamental theorem of calculus. If this is integrate fx equals fx plus c, then if this a, we call it lower bound, b, upper bound. Okay, fx equals fx. This is b upper bound and a lower bound because fb minus fa. What does it mean? Let's see one example. Here, you integrate. This is lower bound. This is upper bound, and 3 x to the power 3 dx. First, we integrate this function, right? The integrated function is quite easy right now for all of you. It's a 3. The x to the power 3 is x to the power 4, right? The power plus 1 over the power plus 1. And then you put the upper bound here, the right top, and then the lower bound, the right bottom, the right bottom. And then later we do the substitution. Substitute x, the upper bound, okay, into x. So you 3 times 5 to the power 4 over 4. And then you substitute the lower bound into x. Again, minus 3 times 2 to the power 4 over 4. And then you use calculator, you can get this number. So, and then also there are some properties. Integral of zero width. So if you integrate a, the lower bound and upper bound the same, and it will be 0. The integration will be 0. Why integration will be 0? It's very easy. Because in the next tutorial, you will learn that the integration is actually help us to find the volume, to find the area. So for example, if this is fx, this is fx. Okay, in the next tutorial, we'll detail them, so don't worry. If this is fx, and then this is from A to B. This is A, this is B. Okay, if you integrate from A to B, it means you need to find the area under the graph. So this is integrate from A to B. But what if this A, this upper bound and lower bound the same? It means that you integrate the area just like a line, right? Just like a line. Okay, there's no area, just a very straight and thin line. No area here. So that's why this is 0. Okay, this is 0. We detail that in next tutorial, don't worry. And next, here, reverse interval property. If we integrate from A to B, like here, from A to B, and then equals what? Equals the negative B to A. So if we change the upper bound with lower bound, and then you add the negative. The definite integral reflects direction because you need to integrate from the left-hand side to the right-hand side. Left to right gives a positive value. To right to left gives a negative value. So here from A to B is positive, and then if you integrate from B to A, it will be negative. Okay, negative. Next, you need to, this is additivity of integrals. This is quite good. It's very good. This integral from A to C, fx dx will equals A to B plus A to C. What does it mean? Very easy. So we can let this be C. We let this be C, okay? I want to integrate the area from A to C, like this. Integrate to find the area from A to C. The A to C, you can see the area A to C is the shady part, right? Okay, it's equals what? A to B, you see? A to B is the area under the graph from A to B. And B to C is the area under the graph from B to C, right? So you can see this whole shady equals the first shady part plus the second shady part, right? So we can code this formula. Now let's do some practice. Here, the definite integral. The constant c of integration is omitted for definite integrals. Don't forget to ignore the constant c, okay? Now let's do it. Here, first, you just do the integration as what you did before. Here, look at that. This is 3, so power plus 1 over the power plus 1. So 3x to the power 4 over 4. And there's minus 5. This is x to the power 1 is 1 plus 2. 1 plus 1 is 2, right? So it's 5x to the power 2 over 2 plus 2x. Constant, you just add x. And then the lower bound is 1, the upper bound is 3, okay? And then we do substitution. The first, you substitute x equal 3, 3, 3, okay? You can get this. Easy to get this. And then also we substitute 1, 1, 1, okay? And you can get this part. And you use calculator, you can get 44. Continue. Next. It's the same, right? Here, I said many times you see the square root or 1 over x or something. You need to raise the power x to power n, right? X to power n. So the square root x is x to power 1 or 2. And 2 over x is 2 times x to power negative 1. Remember, 1 over x equals x to the power of negative 1. Negative 1. Continue. And let's integrate. So 4 times the power plus 1 over power plus 1 minus, this is x to the power negative 1, right? It's ln x. And then you write the upper bound, lower bound. And here, because we said divided by the fraction, divided by fraction means times is reciprocal. Divided by 3 over 2, it means times 2 over 3. So 4 times 2 over 3, 4 times 2 over 3. 2 over 3 is 8 over 3, right? 8 over 3, x to the power 3 over 2, minus 2 ln x, and 6, 2. Now we do what? Substitution. Substitute the upper bound and minus the substitution of lower bound. And then you use calculator, it's around 77.3. We keep 3 significant figures. Next. If you integrate lower bound is here, power 3 to power 2. And here, look at that. This is as plus b, okay? This is linear, okay? Linear. So how to integrate is quite easy. This is as plus b. We need times 1 over a, right? So it's 1 over 2. A is 2, so 1 over 2 times the sign will be negative cosine 2x minus power 3. And then the upper bound, the lower bound. And continue. This is the power 2, power 3. Continue here. So minus 1 over 2 cosine 2x minus pi over 3. 2x minus pi over 3, pi over 2, pi over 3. Here, we do the easy substitution. Substitute x equals pi over 2 here. And then minus the x equals pi over 3. Okay, we do the substitution. And then you can use calculator. This is here, cancel. So it's pi minus pi over 3 is 2 pi over 3. And then this is 2 times pi over 3 minus pi over 3 is pi over 3. And let's continue. So how to find the cosine 2 pi over 3? You can use calculator, of course. Or you can draw the unit circle, ASTC, right? In the trigonometry, we will learn the ASTC. And then cosine 2 pi over 3 is here, right? This is cosine 2 pi over 3 is here. Because this is 2 pi over 3, okay? This is 2 pi over 3. And then the acute angle, the reference angle will be pi over 3, right? Pi over 3 here. And then ASTC, so this is, we choose this, is S. But this is cosine, right? This only sign is positive. So here it will be negative, negative. Okay, so cosine 2 pi over 3 equals negative because it only sign positive. Negative cosine pi over 3, this is reference angle. And cosine pi over 3, we have memorized, right, is actually 1 over 2. So the answer is minus 1 over 2. So here, this is minus 1 over 2. Okay, cosine pi over 3 is 1 over 2. So we can easily calculate equals 1 over 2. Next. Here, if you let's see, find this. Remember we said just now, if you integrate from a to b plus b to c equals from a to c, right? Okay, so 1 to 3 plus 3 to 9 equals from the beginning to the end. You integrate from beginning to the end, from 1 to 9, right? And we were given the first integrate from 1 to 3 is 4. So this is 4. And here we keep this. And this is -3. So -3 here. This is what we need to find, is integrate from 3 to 9 and equals -3 minus 4, right? -4. And so the answer is -7. Okay, next. We suppose this is -2 fx dx equals -9. Find. The first will be integrate from 2, -2 fx dx. Okay, remember we said, okay, this is what we need to get, right? This is 2 minus 2. But what we given is -2. Remember our formula just now we learned? If we change the upper bound to lower bound, okay, we need to add negative sign, right, before. So 2 -2 equals negative. Integrate from -2 to 2. And this is what we get is -9, right? So minus 9 is 9. Next, if we integrate from 2 minus 2, okay, 2 plus fx dx, what we will get is very easy. First, because our lower bound is -2, upper bound is 2, so we can change the lower bound, upper bound first. And we add a negative, so we can change the upper bound, lower bound. And next, we can integrate them separately. Remember, if there is our functions here, we can integrate them separately. So we integrate 2, and then we integrate fx. Integrate 2 will be very easy, right? 2 is a constant, we just add x. So x, and then the lower bound minus 2, this is 2. And here also, this is integrate -2 to x. This is what we get, right, from the question. This is -9, so this is -9. And if we integrate 2x, we do substitution. This is substitution, this is 2, substitute, and minus, look at that, -2 times -2, okay? So this is equals 4 plus 4 plus 9 equals 17. And don't forget this is a minus. Here's a minus, so -17. Next. Here, this is the C will be -2, 2, 3fx. This is quite easy, right? We move the coefficient to the front. So it will be 3 times the integration of from the -2 to 2. So it's 3 times -9 is -27. Okay, last one. Last one, find A. Okay, such that this is -2 a fx dx equals 17. This is quite easy, right? We can move the coefficient to the front. Okay, so a times 2, -2, 17, right? And we already get this is what? This is -9, right? From the question here, -9. So a times -9 equals 17. Then a equals 17 over -9. It's -17 over 9. Okay, that's all for today's tutorial. Thank you very much.